Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today we will learn about sequence and series by Miss Rara. So our content is divided by three. The first is about introduction to number sequence. The second is about arithmetic sequence and series. The third, geometric sequence and series. But before that, you need to know what our subject objective. So in the end of the lesson, you will able to define sequence and identify the different kind of sequence. The second is find the end term or the general term of a sequence for which some initial terms are given. The third, find the common difference of an arithmetic sequence. The fourth, find the common ratio of a geometric sequence. 5. Find the arithmetic means and geometric means. 6. Find the sum of a finite arithmetic sequence and geometric sequence. And the last, find the sum of an infinite geometric sequence. So now we will talk about the introduction to number sequence. Okay, in introduction to number sequence, we have divided by three. The first about sequences, the second criteria for the existence of a sequence, and then the last about type of sequence, and then the last will be exercise, everyone. So now let's me explain about what is sequence. Okay, sequence, definition of sequence is a function which is defined is the set of natural numbers is called sequence. So if you have a set, but that set have a natural number, so it's called sequence. Okay, in sequence, if the each member of sequence is called term, and then we denote the first term by a1 and the second term by a2 and so on, like a100, that's the meaning is the 100 terms. Okay, for example, in here we have 1, 4, 9, 16, 25, 36, and so on. And then we can see in here A, A1 is equal 1, A2 is equal 4, A3 equal 9, and then so on. And then we can see in here if the first term is 1, it's equal to 2 power 1, and then the second term is 4, is that the meaning 2 power 2 power 2, and then the third terms is 9, is that the meaning 3 power 2, and then so on. So we can writing here en is equal n square. So from here we can get if the en is the nth term or the general term. So from here we have the first term, the second term, the third term, and so on until we get the nth term, or we can call this one is general term. Not. And in here should always be a natural number, but for the value of en might be any real number. Okay, everyone? So from here, we want to know about the criteria for the existence of a sequence. What's the criteria? The criteria for the existence sequence, if there is at least one natural number which makes the general term of a sequence undefined, then there is no such sequence. Okay, example. Is en equal to n plus 1 over n minus 2 a general term of a sequence? Why? Is it this the general term, is it a sequence? We can say this one is no, because in denominator n minus 2 is not equal 0, so that's the meaning n is not equal to, because we already know 2 is element of the natural number, so we can say this general term is not sequence, correct? So for the number 2, is it en equals square root of 4 minus n over 2n plus 1 a general term of a sequence? Okay, we need to explain about this one. No. We can say this one. No. Because square root of x is, they have a rules. If x must be more than equal 0, right? So from here we get 4 minus n over 2n plus 1 is more than equal 0. We will talk about denominator. Denominator 2n plus 1 is not equal 0, and n not n is not equal minus half. So we know minus half is not natural number. So the rules is broke. But look at the numerator. Numerator is n equal 4, right? Numerator n equal 4. So this one is when you substitute this one to get when you substitute the natural numbers like minus half until 4, you can take 1, 2, 3, 4 to substitute this the first term until the fourth term until here. So it's just limited because we know because in the general term the value must be undefined. No, not undefined. It's unlimited, right? This one is limited, everyone. So you cannot say this one. You cannot say this one is general term, right? Okay, I hope you understand what I'm explaining. Okay, the third is type of a sequence. Okay, type of sequence divided by 4. The first finite and infinite sequence. The second is monotone sequence. The third piecewise sequence. The fourth is recursively defined sequence. So first we will talk about finite and infinite sequence. What is finite and infinite? A sequence might contain a finite or a finite infinite numbers of the terms, right? So from here, if a sequence contains a countable numbers of the term, then we say it finite sequence. So from here, from the previous example, we have 1, 4, 9, blah, 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 until n square. So we know 1 until n square, this is limited, right? So this call it finite sequence. And then, if a sequence contains infinitely many terms, then we say it infinite sequence. Okay, so in here 1 until n square it's called finite, but after n square it's called infinite. Okay, so let's example. Write the first 5 terms of sequence with general terms en equal 1 over n. So they told us they want to have a 5 first term. So that the meaning they want us to find the n from the 1 until 5. Okay, and then after we get the 1 until 5, you need to substitute to the general term. Okay, general term, the en equal 1 over n. So you need to substitute n to here. So a1 equal 1 over 1 is equal 1. And then when you're doing a2 is equal 1 over 2, and then so on until a5 and equal 1 over 5, everyone. So from here, we have another example. They told us find the suitable general term en for the sequence whose first 4 terms. Okay, so this question is give us the sequences for first 4 terms. Okay, so we have the first term is half, and then the second term is 2 over 3, and then the third term is 3 over 4, and then the fourth term is 4 over 5. So they told us want to find the general term. General term is en. So from here we know that from these sequences we look like why this the first denominator is the same with the second numerator, and then so on. So from here we see 1 over 1 plus 1, and then 1 plus 1 over 1 plus 2, and then so on. And then we can see if we substitute 1 in here, the result will be 1 over 2, okay, in this first terms. And then if we substitute the second term, 2 over 3 is the true again. And then when we substitute the third term, is 3 over 4. And then when we substitute the 4, it's equal 4 over 5. Okay? Now we will talk about the second type is monotone sequence. What is monotone sequence? If each term of a sequence is greater than previous term, then the sequence is called increasing sequence. Okay? If they have greater than the previous term, then call it increase sequence. So the symbol is en is increasing if an plus 1 is more than en. Is that the meaning? The second, you can say the second term is more than the first term. Or, they have, if the second term more than equal the first term, then en is called non-decreasing sequence. So then there's nothing changed. Okay? And then if each term of sequence is lower than the previous term, then the sequence is called decreasing sequence. So we can say the second term is less than the first term is decreasing sequence. If the second term is less than equal the first term, then we can say is a non-increasing sequence. So let's example. From here we have a 10x 4, we can say the first term is 10, the second term is x. 10 to x is minus 2. X to 6 minus 2. So we know this one is decreasing because the first term to the second term is lower. I'm sorry, the first term to the second term is lower than the previous one. So it's called decreasing sequence and its meaning monotone sequence. And then we have B 1, 1, 2, 3, 5. There's nothing changed in here because the first term and then the second term is equal. We can say this one is non-decreasing sequence. Okay. Why I can say this one decreasing sequence? Because the first term and then the second term is the same value, the first. And then the second, when you saw the fourth term is bigger than the third term, so we can call it this one non-decreasing sequence, everyone. Remember, if they have the same value, the second term to the first term, you must look again for the third and the fourth. If the third is less than from the fourth term is called non-decreasing sequence. Okay, and then the C we have 41014. We can see here they doesn't have increasing, they doesn't have decreasing. Yeah, maybe you can see they have missed decreasing or increasing, but in here they have a repeated value. So obviously we cannot put this sequence into any category. So this call is non any category. So this one is not MS, not monotone sequence. The third is piecewise sequence. What is piecewise sequence? If the general term of a sequence is defined by more than one formula. Okay, this one is typo, everyone. By more than one formula. So this one is, for example, the sequence with the general term. So that the meaning they have the general term more than one. So this one is called piecewise sequence. If you ask me, Miss, this is the general term for the piecewise sequence. No, this one just example, everyone. General term is so many type of general term. So this one just one of the many type of the general term. Okay, example. Write the first four terms of piecewise sequence with the numeral term. Okay, in here they have the en equal 1 over n if the n is even, and then 2 over n plus 1 if the n is odd. So they have the rules. You can use this 1 over m for n is even. You can use 2 over n plus 1 if the n is odd. Okay, to find the A2 and then A4, because 2 and 4 is even, you can using the general term 1 over n. So when you substitute, you will get 1 half and then 1 4. Okay, and then to find the first term and then the third term, you can using 2 over n plus 1, because this one is odd. And then when you substitute, you will get the first term is 1. And then the third terms, you will get the half, everyone. Okay? So now we will talk about recursively defined sequence. What is recursively defined sequence? Sometimes the term its sequence might depend on the other term. What's depend? No, what's depend? But they have uh they need another sequence to can find their sequence. Okay, what's that the meaning? Let's see. Given a1 equal 4 and then a n plus 1 it's equal a n plus 3, you need to find the second term and then you need to find the general term of the sequence. Okay, from here we have the for to find the a2, we have n, so that's the meaning that the number of the sequence is 2. So you need to substitute the an plus 1, so equal en plus 3. This one is from the equation, and then we're talking about n, and then you can substitute the n equal to this formula. So a2 plus 1 is equal a2 plus 3. So the third term is equal the second term plus 3. Okay, because we have the one, and then you can put an equal 1, and then you get en plus 1 is equal en plus 3, like this one. And then when you substitute, you get the a2 equal a1 plus 3. Okay, because they're talking about the a2, you can substitute a1 is 4 and then plus 3. Okay, so the result is will be 7, sorry. And then you need to find the general term of the sequence. Okay, from here, you have en. You can see your answer if the second term is equal the first term plus 3, and then the third term is equal the second term plus 3. Okay, from here, if so, you can think in your in your head, you can think about if the second term is equal the first term plus 3, maybe, not maybe, but the third term is equal the second term plus 3, and then so on until a5 equal a4. So if you want to continue, maybe you will think, oh, so en is equal en minus 1, right? Because in here and then in here is different always 1. Okay, so maybe you can think be like that. But you need to know for 2a2, the second term is equal with the first term plus 3. So you need to substitute the a1 plus 3 to be the second term. So a1 plus 3 plus 3, right? And then how about the a3? A3, the third term is equal a1 plus 3 plus 3. A1 plus 3 plus 3, and then their self plus 3. And then so on. And then you will get the formula en equal a1 plus n minus 1 times 3. So en for the general term is equal 4 plus en minus 1 times 3, and then you need to simplify, and then you will get en equal 3n plus 1, everyone. Okay, another example. They're given the 5 term is equal 6 and n plus 2 times n minus 1 terms equal 3 en, where n more than equal to. And then they told us find the third term. Okay, so from here, you need to find the four terms and then the three terms. maybe you curious why. The first you need to find the third terms is because they ask about the third terms, right? And then if why we should find the fourth terms, we can see from this equation. This one en and then n minus 1. We have the 5 everyone from here, right? So we need to find the f4. So we can using the n5. And then we substitute to this formula, n plus 2 times a n minus 1 equal 3 en. And then you simplify, and then you will get f4 equal 18 over 7. Now, you can find the a3, the third terms, I mean. And then to find the third terms, you can choose the n equal 4. And then you substitute. And then you can get E4, the fourth terms. 3 times 18 over 7 over 7. So you will get the result 54 over 49, everyone. So from here, you already done of the type of sequence. Now we can to continue exercise. Okay, you can open your Jambox book, page 16 until 17. In exercise, they have type A, 1C and E, and I mean number 2 E, number 3 C, and then type B, 8, 9, 11, 15, and 16. Okay, everyone. So, thank you for today. For the next meeting, we will talking about arithmetic sequence and series. I hope you enjoy my video. I hope you understand what I'm explaining today. Assalamualaikum warahmatullahi wabarakatuh.